students, welcome to the next session of units and measurements. I gave a small homework problem for you before going to solve that one. So I am going to give this example problem. So the period of oscillation of simple pendulum, they gave time period t is equal to 2 pi root L by G. So measured value of length L is 20 centimeters. Known to 1 mm accuracy. Up to 1 mm accuracy they found. Means the scale, what they are going to find? Length. The length which is going to find, the scale is resolved up to 1 mm. Resolved up to 1 mm means already I gave 3 different scales for it. One scale up to 1 centimeter resolution. Another scale I gave between 0 and 1, 10 divisions. 10 divisions means this is called 1 mm resolution. Another scale I gave between 0 and 1, 20 divisions. 20 divisions means that is 0.5 mm. Okay, or 1 by 20, 1 by 10, 1 centimeters. In centimeters means 1 centimeter. So 0.1 centimeter, 0.05 centimeter. This is resolution. So this resolution they gave 1 mm, up to 1 mm. So means they found by using this scale, this length. Okay. And time for 100 oscillations of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. Wristwatch resolution is how much? 1 second. They found 90 seconds for 100 oscillations. For 100 oscillations it is making how much time means 90 seconds. So what is the accuracy in the determination of G? So G means the relative error or percentage error. Up to what accuracy you got, you will be getting. So in G, so what is the relative error, percentage error we have to calculate. So from this equation, T is equal to 2 pi root L. We have to find G. So we should bring this one this side. Whenever we are bringing, so sparing on both sides because we have to eliminate this root. Sparing on both sides. Sparing on both sides, T square equal 2 pi whole square. 4 pi square L by G. Correct? I am sparing on both sides. Here T square, 2 pi whole square, 4 pi square, square root and root will be cancelled. Now G is equal 4 pi square L by T square. So because of 4 pi square you won't get error because 4 and pi is constant whoever doing the experiment. They are going to get error by measuring length and time period. So yesterday I gave this type of equation. So L power how much is there? 1. T power how much is there? 2. Then percentage error or relative error in G. How we will write? Relative error delta G by G. L power how much is there? 1. 1 into delta L by L. So they gave here capital L. I wrote here small l. So you can change this one as capital L. That is our question, no problem. Because in question they gave capital L. So delta L by L. T power how much is there? 2. Therefore plus or minus? Plus only delta T by T. So what is delta L? What is the resolution in length? Accuracy means 1 mm. Therefore delta L is 1 mm. But length how much? 20 centimeters. This is in centimeters, this is in millimeters. This one converted into centimeters. So 1 mm means 0.1 centimeter by 20 centimeter plus 2 into delta T. Up to what resolution? Delta T is 1 second. So therefore 1 by. So how much time you got? 90 seconds. So 90 seconds for 100 oscillations. They are asking for 100 oscillations time period there. Okay. So 2 by. So this one you can solve. So you will be getting answer 0.1 by 20. How much you will be getting? So 0.1 by 20. So 2 by 90. They gave almost 0.027. Just you can solve this one. 0.027. Why around centimeters means here some people will write this 1 mm directly 1 by 20 they will do. 1 by 20 if they do means that is wrong. Why? Because both should be in same units. This is seconds, this 0.027 they gave. So this is delta G by G. Percentage error means what you have to do? So delta G by G into 100 is equal to 0.027 into 100. So that is nothing but 2.7%. 2.7 is they gave 3. So almost it is equal to 3. So final answer is 2.7%. So yesterday I gave homework for you. So kinetic energy relation I gave of mv square. So percentage error in mass, delta m by m into 100 is equal to, I think I gave 1%. Percentage error in velocity, delta v by v into 100, that is nothing but 2%. I think I gave 1% and 2%. So substitute here. M power how much is there? 1. V power how much is there? 2. Therefore, percentage change in kinetic energy I asked. So delta Ke by Ke is equal to 1 into delta m by m into 100. Because m power 1. Because of half 1 by 2 you won't get error. Either percentage error or relative error. Therefore, half you no need to take. Plus 2 into delta v by v into 100. So delta m by m into 100 how much? 1%. Therefore 1 into 1% plus 2 into velocity how much you got? 2%. They gave. So 1% plus 4%. 5%. So if you take 1% in mass, 2% in velocity, your final error, percentage error in kinetic energy, so into 100. This is nothing but 5%. Okay, so very important model in the point of competitive also, but this one they gave in PU example model. Now next topic here, topic is significant digits or significant figures. Okay. So next topic is significant digits or significant figures. Significant digits or significant figures, very important one and easy one also. You will be getting in your chemistry also this one, significant digits or significant figures. So we measure some values, we got some error. Let us assume while measuring length of an object, so this is a scale which is resolved up to 1 centimeter. This example I gave. Now what is the length of this object? Length L is equal to, so 1 is it is cross, therefore 1 point. This one it is in between 1 and 2, therefore we have written 1.5. This 0.5 is assumed. This one only we said uncertainty. That one only we said error. Error is coming because of this uncertainty. The uncertainty in the measurement is called error. So this is true value or reliable value. Reliable value, this is uncertain. So in any measurement of number, the combination of reliable number and uncertainty number. Reliable value, uncertainty value. So reliable value, uncertain value is called significant digits. In any measurement, you will be having both reliable and uncertain. So define significant digits or figures means, so it is the combination of both reliable and uncertainty numbers. That is called significant digits. Now, what are the rules to say significant digits? In that number only, 1.5 if you have taken. So how many significant digits are there in this? So in this 1, 2. So 2 significant digits are there. So 2 significant digits are significant figures. So what are the rules? So rule number 1. So you have to write carefully all the non-zero digits wherever the decimal place is there, all will be coming under significant digits. Okay. So you gave one number. All the non-zero digits. Zero digits means zeros, non-zero digits means except zero remaining all numbers will be coming under non-zero digits. So all the non-zero digits without decimal place, wherever decimal place is there, not there, all will be coming under significant digits. I am going to give example for you, then you will understand well what I said. Let us say 1.534, 15.345, 6.213, 6234. I gave here some numbers for you. All these are non-zero digits. Therefore, in this, how many significant digits are there? Means 4. 1, 2, 3, 4. So decimal place is there, but we don't need to worry about decimal place. What I said first one, all non-zero digits, wherever decimal place will be coming under significant digits. In this 15.345, in this how many significant digits are there? 1, 2, 3, 4, 5. Therefore, 5 significant digits. So wherever decimal place, we don't need to worry. 6.213, in this 4 significant digits. In this there is no decimal place, but all the digits will be coming under significant digits. Understood now first point? So all the non-zero digits, wherever decimal place is there, are significant. So in your textbook they gave simply all the non-zero digits are significant. That one they gave. But wherever decimal place is there also, you can say those will be coming under significant digits. So they will give numbers at the time. How many significant digits are there? They will ask. Up to now you know only one rule. That is, all the non-zero digits will be coming under significant digits without regarding or without no need to worry on decimal place. Okay, next I said about non-zeros. If zeros are there, how the significant digits will be coming? So all the zeros. So in between two non-zero digits are significant without regarding decimal places. So all the zeros in between two non-zero digits are significant without any decimal place. What does it mean? This is the rule. Then how to give example for this? How to give example? This one means, so 2002, isn't it? So 20101. See, zeros are there. So these will be also are significant. So 2000. This zero is there in between 2 and 2. These twos are non-zero digits. Therefore, two zeros are there in between two non-zero digits. Therefore, these two zeros are also significant. Now in this, how many significant digits are there? Means 4. So problem will come whenever zeros are coming on. Okay. So but this is one rule. Whenever zeros are coming between two non-zero digits, always those zeros will be coming under significant. So this zero is there between 2 and 1. Therefore, this zero is also significant. This zero also significant. Therefore, already I said non-zeros are significant. Therefore, in this how many significant digits are there? 1, 2, 3, 4, 5. 5 significant digits. And I said without regarding decimal place. Without regarding decimal place means see. So 2.0305. So 20.401. Okay. So in this, how many significant digits are there? Again, 0 is there in between 3 and 2. 0 is there in between 3 and 2. Even though decimal place is there, you no need to worry. This 0 also significant. This 0 also significant. Therefore, total how many significant digits are there? 1, 2, 3, 4, 5. 5 significant digits. In this, 20.401. 20.401 means this 0 is there in between 2 and 4. 2 and 4, two non-zero digits. Therefore, this 0 also significant, this 0 also significant. Therefore, in this how many significant digits are there? 1, 2, 3, 4, 5. Therefore, 5 significant digits. So I gave one rule here and I gave some examples for this. First rule, all the non-zero digits. This is simple to understand. So but whenever zeros are coming, so there little bit difficulty will be coming. So now this is one rule. So the zeros in between two non-zero digits are always significant without regarding any decimal place. Wherever the decimal place is there, you don't need to worry. So all these numbers I gave greater than 1, isn't it? So 1 point, 15 point, 6 point. So 2000 to 20101. So all these are greater than 1. So when the problem will occur means whenever it is less than 1. Less than 1 means, just I am giving example, 0.00105. 0.00105. In this, how many significant digits are there? So according to rule, all non-zero digits. How many non-zero digits are there? 1 and 5. So therefore those two are significant. This 0 is there in between 1 and 5. Therefore this 0 also significant. So according to these two rules, we got 3 significant digits. But I didn't give about this information. So these zeros will be coming under significant or not. So that is rule number 3. According to this, the zeros after the decimal place and before the non-zero digits. The zeros after the decimal place, this is numbers below 1. Below 1 means obviously here 0 will be there. Okay, above 1 means here 1 point will be there. Isn't it? I am saying about less than 1. So the zeros after the decimal place and before the first non-zero digit. This is the first non-zero digit are not significant. These are not significant digits. Therefore, how many significant digits are there in this? 3 significant digits are there. Okay. So the zeros after the decimal place or before the first non-zero digit. After the decimal place, the zeros after the decimal place and before the first non-zero digit are not significant. Therefore, in this 3 significant digits are there. Another example, 0.0524. So in this 0 is not significant. This is the 0 after decimal place and first non-zero digit. This is the first non-zero digit after the decimal place. This 5 is the first non-zero digit after decimal place. This 4 is the last non-zero digit. Okay. So therefore, zeros after the decimal place before the first non-zero digit are not significant. Therefore, in these 3 significant digits, in this also 3 significant digits. Like that, you can take any number, in your own number you can write 0.00101. So in this, how many significant digits are there means? These 3 are not significant. Therefore, these 3 are significant. Therefore, 3 significant digits. 0.0006. So in this, how many significant digits are there means? All these zeros are not significant. Therefore, only 1 significant digit. So numbers won't come like this only. Numbers will be right like this also. I am saying less than 1. So in that case, so now always you are writing with non-zero digit you are ending. After 6 zeros are there, what will happen? What will happen means we will see. Same example we will see. 0.001050. 0.001050 they give. So for this, how many significant digits are there? So now this rule is a third rule. The zeros after the decimal place before the first non-zero digit are not significant. So same rule will follow. Therefore, these zeros are not significant. But here one problem is there. Even last number also 0. Then this 0 is significant or not. That one next rule. What is that rule means? This rule is the zeros after the decimal place before the first non-zero digit are not significant. Now this 0 name is 0 after the decimal place and after the last non-zero digit. So here, this is the last non-zero digit. After the last non-zero digit, any 0 is there means that will be significant digit. Now, therefore, this 0 is significant. Therefore, in this how many significant digits are there means 4 significant digits. This one 0.0, 5, 2, 4. I again have taken 2 zeros. So this 0 is not significant. Now these 2 zeros are significant because these 2 zeros are after decimal place and after the last non-zero digit. After the last non-zero digit, any zeros are there means those will be coming under significant. So before first non-zero digit, not significant. After the last non-zero digit, so those will be coming under significant. In this, how many significant digits are there? 1, 2, 3, 4, 5. So therefore, 5 significant digits are there. Understood? So this one you can take 0.0010, 0100. This is one number there. In this, how many significant digits are there? So these two are not significant. So 1, 2, 3. This 0 is significant. Why? Because between two non-zero digits. This 0 also significant between two non-zero digits. These 2 zeros are also significant. Why? Because last non-zero digit later those are there. Therefore, total how many are there? 1, 2, 3, 4, 5, 6, 7. Therefore, 7 significant digits are there. So greater than 1 numbers. All the non-zero digits are significant wherever decimal place is there. So all the zeros in between two non-zero digits are significant. So wherever, without regarding any decimal place, you don't need to worry about decimal place. If number is less than 1, 2 cases will be coming. So before first non-zero digit, zeros are not significant. After zeros, after the last non-zero digit, after the decimal place are always significant. So numbers will be coming like this only, or still any models will be there. So still more models are there. So what are the one means? Some people will write powers, 10 power they will write. If you have taken mass of the earth and the acceleration due to means gravitational constant g 6.67 into 10 power minus 11. 10 power minus 11 Newton meter square per kg square, and 1 AMU, atomic mass unit we wrote. 1 U is equal to 1.66 or 67 into 10 power minus 27 kg. Okay, so 10 powers will become. Whenever 10 powers are coming, so these 10 powers you no need to worry. 10 power how much is there also you no need to worry. In this 6.67, therefore we have to consider only number. This number, within this number, how many significant digits are there? In this, all are non-zero, therefore all are significant. So 1, 2, 3, 3 significant digits in this number. So in this number, how many significant digits? In 10 powers, you no need to worry whether it is positive or negative. So 1.66. So 1.66. So 3 numbers are there. 3 are non-zero. Therefore, 3 significant digits are there. So numbers will be coming like this. So still any other numbers are there means we can check once. So all numbers almost you will be getting like this. But whenever you are writing significant digits according to significant digits with units, you should not say change number of digits. Means number of significant digits you should not change. So almost we discussed decimal place, without decimal place, and 2002, 20101. So less than 1. Greater than 1 and powers by discussed. So I gave one number for you. Now 2020, this year 2020. In this, how many significant digits are there? 2500 or 2500. 1000. Now, how many significant digits are there? So with this, if I give any number, you can write how many significant digits are there. In 2020, how many significant digits are there means whenever it is coming to pure number means without decimal place. Okay, so without decimal place any number they give with zeros. Then this 0 is not significant. So 0 after the decimal place significant, but this 0 is in a number not significant. Therefore, in this how many significant digits are there? 3. In this how many significant digits are there? 2. In this how many significant digits are there? 1. Why? Because these 3 zeros will not be coming under significant. Why? Because this is number. So if it is decimal place, 1.000, then in this 4 significant digits are there. If this number we have written 20.20, in this 4 significant digits are there. Why? Because this 0 will be coming under last non-zero digit, isn't it? So you have to take care of pure number means zeros are not significant. Decimal places means last zeros are significant before first decimal place, after decimal place and before first non-zero digit are not significant. Okay, these are the significant rules to say the numbers, how many significant digits are there. Now we will see some examples what they give in our textbook. See some example they gave 0.007. In this how many significant digits are there? So now we saw all the rules. These zeros are not significant, therefore one significant digit. In this 10 power either plus or minus 24, we don't need to worry. In this all are non-zero, therefore 3 significant digits. In this 2370, 0.2370, 1, 2, 3, this is also significant, therefore 4 significant digits. In this 6.320, this is also significant, therefore 0.6.032, this 0 also significant because 0 in between 2 non-zero digits without decimal place, 4. So in this, these zeros are not significant, 1, 2, 3, 4. 4 significant digits. And I told you whenever they are writing any number, they give the units. Whenever we are writing units, significant digits should not be changed. Let us assume length of the object 23 centimeters or 23 meters. Let us use centimeters they give. So how many significant digits are there in this? 2 significant digits are there. So convert centimeters into meters. Whenever you are converting centimeters to meters, this significant number digit or significant digits or figures should not be changed. How many significant digits are there in this? 2 significant digits. Now convert it to meters. 1 meter is equal to 100 centimeters. Then 1 centimeter is equal to 1 by 100 meters. Therefore 23 by 100 meters. How we will write 23 by 100? 0.23. Can we write 0.23 meters? In this how many significant digits are there? Again 2 significant digits are there. Otherwise this one we can write 23 into 10 power minus 2. In this also 2 significant digits are there. If they ask us to convert into millimeters, so 1 meter is having 10 centimeters, 100 centimeters. 1 centimeter is having 10 millimeters. Therefore, 1 meter is having how many millimeters? Means 1000. 0.23 into 10 cube millimeters. If you multiply this number, so if you multiply, how much you will get? 230. 230 millimeters. In this also, how many significant digits are there? 2 significant digits are there. In this, 2 significant digits are there. Because 10 powers we don't need to work. Therefore, whenever you are converting units, so this number of significant digits should not be changed. Okay. Next. Rounding of numbers. Rounding of numbers. So, according to significant digits. Now we are rounding the numbers according to significant digits. How we will round? For this, again, 3 rules will be there. If you are rounding up to how many number of significant digits? Let us assume 12.53467. So this is one value. 12.53467. Just I am giving you the example. You can take your own example and come. In this, how many significant digits are there? All are non-zero. Therefore, 1, 2, 3, 4, 5, 6, 7. 7 significant digits. So round this number up to 4 significant digits. Okay. So round this number up to 4 significant digits there. 4 significant digits means 1, 2, 3, 4. These 4 numbers should be. Then whenever you are removing, you should not remove directly. So this is the last preceding digit, removing digit. This is preceding digit. Before removal digit, preceding digit means sidewise it does. So 4 is going to remove. Otherwise from here also we can start, but directly we can start from here. Both will be same. So this is nothing but removing. What we are going to remove means here 4. If this removing digit is less than 5. Removing digit is greater than 5. Removing digit is equal to 5. Three cases. Now this 4 is less than 5. So whenever it is less than 5, it remains same. Okay. So therefore, this number we can write 12.53. Now in this, how many significant digits are there? 7 significant digits are there. Now in this, we converted up to 4 significant digits. This is rounding of a number. So we rounded up to 4 significant digits, because for sometimes calculation we won't take all these decimal places. Only 1 or 2 we will take. At the time we have to round like this. Okay. So they asked this one up to 5 significant digits. This is up to 4 significant digits. Now they are asked up to 5 significant digits. 5 significant digits means 12.53, 4, 6, 7. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 means this is the removing digit. So this is the preceding digit. Now preceding digit is going to be raised by whenever removing digit is greater than 5, because 6 is greater than 5. Less than 5 means 3 remains 3 only. Okay. So removing digit is less than 5. Preceding digit remains here. So that is in physics language there is a preceding digit. Simply, so before removing digit, how much number is there? That one remains same if it is less than 5. Okay. So removing digit is greater than 5. Then preceding digit is going to be raised by 1 always. Now 6 is greater than 5. Therefore, this 4 should be raised by 1. Then what is the final answer? Means 12.535. We should not write 4. We should write 5. Why? Because removing digit, okay, is going to be greater than 5. So less than 5 means remains same. Greater than 5 means we have to add 1. Okay. So you can take some examples for this. So 1.256. 1.234. Okay. So in this, how many significant digits are there? 1, 2, 3, 4. 4 significant digits. Round this number up to 3 significant digits. 3 significant digits means 1.2. This one is going to be removed. 1, 2, 3. 6 is greater than 1. Therefore, 5 should be added by 1. Therefore, 1.26. Now in this, 3 significant digits are there. In this total, 4 significant digits are there. Round this number up to 3 significant digits. Then 1.23, because 4 is less than 1. Whenever this removing digit is less than 5, this remains same. So now in this also 3 are. So even 0 is also there. Greater than 0 is there. 1.230. 1.230 means 0 is less than 5. Therefore 1.23. Okay, now it is clear. Less than 5, greater than. Now problem will come whenever removing digit is equal to 5. So whenever removing digit is equal to 5 means this number only can be 1.256. How many significant digits? 4 significant digits. So round this number up to 2 significant digits. 2 significant digits means 1.2. 2 significant digits. Now removing digit is equal to 5. So till now we said if it is greater than 5, raise 1. If it is less than 5, remains here. Now removing digit is equal to 5. Whenever removing digit is going to be 5, this preceding digit, the preceding digit before 5, what is the nature of this one? Is it even or odd? So here 2 is there. 2 is even. Whenever it is even, it remains same. Therefore 1.2. In this, 2 significant digits are. They have given one number. They asked us to round us up to 2 significant digits. Therefore, this preceding removing digit is 5. Equal to 5 means preceding digit is even. Even means remains same. If preceding digit is odd, that is some number they give 1.356. So in this 4 significant digits are there. So round this up to 2 significant digits. 2 significant digits means this 5 is going to be removed. So 1 point. So this 3 is nothing but odd number. Whenever it is odd, you have to add 1. So 1.4. Okay. So less than 5 means it will be coming as it is. Whatever number is there, you have to write preceding digit. You should not. If it is greater than 5 means preceding digit should be raised by 1. If removing digit is equal to 5, then preceding digit is even means it remains same. If it is equal to 5, preceding digit is odd means it should be raised by 1. Okay, so whenever it is equal to 5, you should think about even or odd. When it is less than 5, greater than 5, very easily you can. I hope all of you understood. This is called rounding of numbers up to given number of significant digits. Okay. So till now we discussed about significant digits. How many significant digits are there? Later we discussed rounding of numbers. So they will give some significant digits and round it up to 2, 3, 4 significant digits, and whenever how to remove and how to write the rounding of numbers we discussed. Now arithmetic operations. Arithmetic operations means addition, subtraction, multiplication, division. So multiplication, division, addition, subtraction you will be coming to know, but according to significant digits we should do. Okay, so how to do that one? With the example only I will say. First I will do multiplication. Both multiplication and division you have to follow these rules. Addition and subtraction will be other rules. Both will be almost similar. Small change will be there. We will see. So I get some numbers for you. 2.1 into 3.14 into 4.167. So what we will do means multiply means we will take calculator and we will type all this. So okay, not like that. This multiplication we should do according to significant digits. So how to do significant digits means first we have to see how many numbers they give. In this, 3 numbers they give. 1, 2, 3. 3 values they give to multiply. Next, among all these, which is having least number of significant digits? That is the thing called n. What is n here? Least number of significant digits. Now what is n value means here? In this how many significant digits are there? 2. In this how many significant digits? 3. In this how many significant digits? 4. So total 3 numbers. In this which is having least number of significant digits? First number. That is nothing but 2 significant digits. Now n value is here 2. Okay. So just rules I am saying. So in exam also how to solve also I will say for you. If they give an exam. So n is equal to 2. So given numbers, least number is 2. Now except these 2, remaining should have n plus 1 significant digits. That is nothing but 2 plus 1. 3 significant digits. So in this already 3. But in this 4 are there. We should round it up to 3 significant digits. Therefore 2.1 into 3.14 into. In this also you should have 3 significant digits. Round this number up to 3 significant digits means you have to remove 7. 7 is greater than 5. Therefore 6 is going to be raised by 1. 4.17. Okay. Now multiply all these. So you will get some rough value I am saying. 2, 3, 4. So 2 3s are 6, 6 4s are 24. 24 point something or 25 point something you are getting. So 20.34 or 20. Just I am saying, just you can calculate with calculator, you will be getting one value. And last one, first step is we find how many number of least significant digits are there. Next we did all remaining, except that least remaining all numbers should have n plus 1 means here 2, therefore 2 plus 1. If it is 4, 4 plus 1 like that. And last step, final answer should be in terms of least number of significant digits. Least is how much? 2. In this, how many significant digits are there? 4. Therefore, we should remove 1, either 24. Here we should remove 3, either 25. In this, how many significant digits are there? 2 significant digits. This is one method for multiplication and division. First, we have to find which is having least number. Next, we have to see remaining number should have n plus 1 significant digits, and answer should have least number of significant digits. That is nothing but 2 significant digits. Understood? So some people will do directly. Directly means they will multiply these numbers, this into this into this, and the final answer they should do in terms of least number of significant digits. In this 2 significant digits, final answer also we should have two significant digits. So you will also get almost both will be same one. So next I am giving 3.14 into 4.345 into 1.325. So in this this one. So in this I gave 3, 1.3. How many significant digits? 3. Here also 3. Here only 1, 2, 3, 4. Here 4 are there. Okay. Here 2 numbers. Least is how much now? 3. So this one is 4. Directly it is. If it is not there directly also, you can multiply. But final answer you should have in terms of 3 significant digits. Understood? Always final answer you should have in least number of significant digits in case of multiplication and division. So rule for that one is, first we have to identify among the given numbers how many least number of significant digits are there. So after getting multiplied or divided, so final answer you should write in terms of least number of significant digits. This is for both multiplication and division. Okay. Next, addition and subtraction. So we will do addition, subtraction also same. For addition and subtraction, what they will follow means, let us take some values. 2.31 plus 1.423 plus 1.425. So I get 3 values to add according to significant digits. Again same, we have to take like this, but not significant digits. We have to take decimal places. Decimal places means after decimal how many places are? In this 2 decimal places, in this 3 decimal places, in this 3 decimal places. Again same rule. Least number of decimal places, remaining number should have 3 decimal places because this is 2, therefore remaining already there. Therefore add direct. And final answer also you should write in terms of least number of decimal places. So 2.31, 1.423, 1.425. So 5 plus 3, 8, 5. So 4, 4, 8, 8 plus 3, 11, 1, 3, 4, 5. This is the final answer. Final answer you should write in terms of least decimal places. That is nothing but 2 decimal places. 2 decimal places means you should remove 8. 8 is greater than 5. Therefore 5.16. 5 should be raised by 1. If it is less than 5, it remains same. Understood? 5.16 is the final answer. According to decimal places you have to do both addition and subtraction. According to significant digits you should do for multiplication and division. So they gave some examples in our textbook. You can see, you can get understood with those values. Okay. So this is about today entire discussion on significant digits and rounding of numbers, how to round the given numbers, and after rounding how to do multiplication and division, how to do addition and subtraction according to significant digits. So our next topic is dimensional formulas. So we will see. So our next topic is dimensions. Dimensions of physical quantity. So already I gave definition for physical quantity. There are 2 types of physical quantities, fundamental and derived. All these will be coming to know. What is the dimensions of that physical quantity? So first we will take any one physical quantity you can take. That is nothing but mass, length. Length I have. I am going to find height of an object. So height of this wall. So this height is physical quantity. Okay. So to represent this height, I require fundamental physical quantity. That is nothing but length. Length is going to be denoted by L. Isn't it? So this L, height L, we are representing with length simply. If you have taken volume, just before going to give the definition of dimensions, just I am giving examples. Volume. Volume means length into breadth into height. So LBH. This is nothing but L into L into L. Because length is fundamental, breadth is also fundamental, height is also fundamental quantity. So fundamental physical quantities means, I told you first length. Length means under length you will be having so many: length, breadth, height, radius, diameter, wavelength. So which will be coming under Fermi, parsecond, all these will be coming under length only. Okay, so all these will be coming under same physical quantity. How you will give all the names are same charge. So you will be having so many different names without knowing to you. So how you will be having different names means, so once you are sitting at home now, so you are child, son or daughter. Once you are coming for society, you will be calling it as citizen, isn't it? So once you are going for theatre to watch the movie, you will be the audience. So you will be acting in that movie. You will be the actor. In that also so many will be there: hero, heroine, side character, comedian. So you will be having so many names, same like that, but all will be coming under you only. This is also same. All different. All height, breadth, radius, diameter. All these will be coming under length only. So L into L into L cube. What we have taken physical quantity in LHS? Volume. Here height we have taken. Height we have taken. We wrote L. Like that area. Because all these are simple, you will be coming to know. Therefore I am giving. Area means length into breadth. Therefore what you will write this from? L square. Area A is equal to L square. Now what is the dimension? What is the dimension means? To represent this physical quantity, which physical quantity I represented here? Area. To represent area, I raised fundamental physical quantity or base quantity to the power of 2. Means, so this 2 is called dimension of this physical quantity. To represent a physical quantity, up to what powers we raised of the base quantities, up to what powers we raised of the base physical quantities or fundamental physical quantities. So those are called dimensions. These powers are called dimensions. Here power of the length is how much? 2. So 2 is the dimension of fundamental physical quantity length. To represent volume, same fundamental physical quantity I raised up to 3. If you raise up to 2, it is representing area. If you raise up to 3, it is representing volume. Understood? So to represent height, I raised fundamental physical quantity power to 1. Understood? So all this is 3 is dimension, 2 is dimension, here 1 is dimension. So take one physical quantity. Any other? You came to know in motion in straight line, velocity. So velocity is equal to, what is the definition? Displacement by time. Displacement by time. So displacement is going to be denoted by L. So we wrote fundamental physical quantities, 7 fundamental physical quantities: length, mass, time. I told you representation also. Length is going to be denoted by capital L. Mass is going to be denoted by capital M. Time is going to be represented by capital T. Time is going to be represented by capital T. Here LHS velocity. So L power 1, T power, this T is going to numerator. L T power minus 1. If you raise fundamental physical quantity length power 1, so fundamental physical quantity time power minus 1. Then you are getting which physical quantity here? Velocity you are getting. Okay. So the powers of the fundamental physical quantity, up to what power you are going to raise, those powers we are calling it as dimensions. So this equation we are calling it as dimensional equation. The equation which is representing physical quantity and fundamental physical quantity powers or with dimensions is called dimensional equation. So we will write so many equations you will be having, so which are related to first PU and second PU. So the dimensions of a physical quantity are the powers to which it is going to be raised to represent a physical quantity. So we are representing on physical quantity. So by raising fundamental physical quantity power to the 2, then we are representing area. Okay. So all these are different dimensions. This 3 is dimension, this 2 is dimension for area. So for velocity, so length is going to be raised by 1, time is going to be raised by minus 1. Then you will represent velocity. Okay. So now this is called dimensional formula for velocity. This is dimensional formula for area. This is dimensional formula for volume. By representing, we have to take closed brackets. Okay. So up to what powers we raise, these powers we are calling it as dimensions. So if you relate the equations, after raising, it it's the base physical quantities to some powers. If you are representing physical quantity and up to what powers you raise, fundamental physical quantities or base physical quantities up to what powers you raise. If you equate these two, so that is called dimensional formula. So dimensional formula, dimensional equation is the equation or expression which is representing the physical quantity in terms of fundamental physical quantities. So this is physical quantity in terms of fundamental physical quantities by raising to some powers. So you can say any other physical quantity, then I will write the dimensional formula. What is that one means? Let us assume you came to an acceleration. What is the dimensional formula for acceleration? So A. So what is the dimensional formula for acceleration means? What is the acceleration definition? Velocity by time. Velocity L t power minus 1. Time we wrote it because velocity came from here only, L t power minus 1 directly I wrote. So time t only. Therefore L here it is going to numerator. Therefore L t power minus 2. This is the again dimension formula for acceleration. So by raising power of the length base quantity to 1, by raising base quantity of time to minus 2, we are getting acceleration. So these powers are called dimensions of acceleration. Understood? Next another one, force. Write the dimension formula for force. I am writing all those big physical quantities already you came to know. This is, we can't end this lesson. From first year we will be starting till second year you will be getting dimension formulas. End of the second year lesson. Force equation you came to know, mass into acceleration. Already you got acceleration here, L t power minus 2. I am not writing once again, directly I am writing. For mass, what is the representation for mass? Mass is for capital M in terms of powers, m power 1. Acceleration, L t power minus m L t power minus 2. So m L t power minus 2 is the dimensional formula for force. So still that n number of dimensional equations will be coming, but you should come to know all the physical quantities equations. And the next one, density. I think you heard about density. Density dr rho is equal to mass per unit volume. So mass value capital M with the base physical quantity, volume is L cube, then m L power minus 3. So you can represent density if you raise mass power to 1, if you raise length power to minus 3. So these are nothing but dimensional formulas and how to write. And how to write that one easily, so we will discuss in our next class. Okay.